So, hello everyone. All of us might have used databases in our projects very often, I guess. So, some of the databases we all might have used are SQL, NoSQL databases. If you're aligned to AML and stuff, you might have used Pinecone or ChromaDB or Milvus. All right. For this database is like a black box. You run some query, you get some output, right? So, and you get some output. So, it was a black box for me too until I actually tried to learn what exactly happens in between the query and the output. Okay, so what would be the best way to actually know what happens in this black box? Maybe you could read a book. Books are a good source, actually, but it's quite boring, right? So I decided to read the source code of popular databases like Redis and SQL. As you know, all of them are open source. You can access the code. So I accessed the code. Most of the code was in C, C++, and I had trouble in doing that CMake thing in Windows because I wasn't able to configure it. I had MinGW32. I uninstalled it, then installed my MSys MinGW64, but the attempt was failed. So I decided to somehow make a database by myself because the source code was just not enough. That was just theoretical learning. I actually wanted to know how algorithms inside a database work. So I tried to make my own database and I named it as MilletDB. So it's made in Java and Java Coffee Bean Millet. So the naming is, I hope, pretty clear and I believe it's very creative on my side. So let's study the source code of my database. So since it's very basic, so that we can actually understand how databases work. So it all began with a linked list node, a doubly linked list node. So the people who say we don't use DSA in development are obviously lying. So it all began with a doubly linked list node. So I chose a key value pair. The linked list node should store a key value pair. And why a linked list? Before understanding any data structure, we need to answer the question why. So as all of you know, database has more number of insertions and deletions, and it's more likely that data is valuable, right? So most often any database would be likely having more number of insertions than more number of deletions. If I take any other thing like an array or something like that, deleting would be a trouble. Shifting things, you all know, right? Linked list insertion as well as deletion, both are quite easy. And doubly linked list, because I don't know how user will be querying it, could be bidirectional. All right, coming back to the source code, it's a doubly linked list, and we are implementing an LRU cache on the doubly linked list. Yeah, it's a popular lead code question. If any of you know, it's a popular lead code question. It's the same algorithm essentially, but the difference is that the data type we are using is the custom node data type, and we are using a hash map and stuff. So it's a customized LRU cache, I would say. On that part, coming to the LRU cache, let me tell you what is LRU cache on a very high level. LRU cache is least recently used cache. So what's it exactly? Say there's a school's database and it's using this sorry, this millet database, my millet database from the year 2025. So most insertions and deletions would be done on this year 2025 because it's the current year. It's the current year, so the most insertions and deletions would be done on that peculiar part of this year, right? Now let us say a few years past, it's year 2028. All right, it's year 2028. Now um, currently the most insertions would be done on 2028 year, right? The current year admissions, fee payments, and exam marks, etc. All these things would be insertions and deletions would be done mostly on this year. So this becomes the least recently used cache, right? This becomes the least recently used data. So it should stay on top so that access is fast. That's what LRU cache is all about. The data which is used long ago, it's basically given less priority, like it's on the bottom. The least recently used is on the top. Okay, so it's a linked list based algorithm. So what's the use of it? This is essentially to make the database faster. It gives O of 1 retrieval time, which is quite amazing for any database. SQL and Redis, both of them, I guess, use it, if I'm not wrong. And coming back to the source code once again, I have done something known as sharding. Sharding. It's a system design concept, sharding. So what sharding is, you basically chunk the data. You basically divide the data into several chunks so that uh, you don't end up a single entity using a single data. Instead, several entities can use multiple chunks of data at the same time. Not at the same time, that would become concurrency. We will discuss about it later. But sharding is like, since, see, if you grab the data, all the data at once, if it's a huge database, um, you would end up allocating more memory to it. You would end up allocating more CPU to it, more compute to it. So it's not healthy. If you're dealing with a particular chunk of data, you will just deal with a particular chunk of data. So that's what exactly sharding is in this case. So that's a very brief overview on sharding. It's a very deep concept. I guess all of you should study about it. Like all of us should study about it. It's uh, something very deep. So yeah, sharding is all about chunking on a very high level. So back to the code base. Now I have done several testing on it with JUnit. Okay, I tested the key value store separately, server separately, and the snapshot feature. This is something um, I really loved about the database. So it continuously gives you these snapshots. If the server is running, the server is continuously monitored by these snapshots. And if you open any of them, you get the shards which took place and timestamps, etc. Okay, so this is one feature, and we are done with sharding. LRU cache also has a latency benchmark, and you can view the stats anytime. Now let's come back to the interesting concept of concurrency. So concurrency once again is a system design concept. So let's understand how concurrency works. What is it exactly? So concurrency is something like, if I'm my user A, and there's some other user B, 5:45 p.m., 6 seconds, 23 milliseconds, and you can take it up to any precision. The time is exactly same. The time is exactly same. And user A wants to do some process, user B wants to do some process at exactly this time. Since both of them came at the same time, you cannot just delay one user and give the chance to another user. You cannot do that. The next thing you cannot do is stop the process of one user, like completely stopping, not pausing. I'm using the words very carefully, not pausing, actually stopping the process. Then, like you take it as a single thread, even if they are both at the same time, one process would be executed like lottery. It's like a lottery. Actually, like there's a OS scheduling algorithm which works in a similar way. Uh, lottery scheduling, I guess the algorithm. Yeah, randomly one process gets executed. That's what you can do, which is not expected. Uh, like that shouldn't happen, right? Both came at the same time. Both should be served equally. So concurrency is like you take two separate threads. If this is 5:45:06:023, if this process also takes place at the same time, you take them parallelly, like parallelly processing them. This is concurrency. Okay, so it's now it's not random luck. One process is not getting stopped, and both processes are being done at the same time. So this is concurrency. Next thing is a very important concept. Once again, this took me a while to understand. Concurrency also took me a lot of time to understand. So next concept that comes is locking. So what's locking? Locking is very interesting because there's a lot of real time use to it. Concurrency also has lots of real time use, but locking is something you can understand by a real time example. So let us take a person C has an amount 1,000 in his bank. C gives access to his bank account to two users, A and B. A withdraws the amount rupees 700. Let's say some random amount 700, and B withdraws 500. So what's the total amount that's withdrawn? 1,200. That means the balance that's remaining is, if say it's you can withdraw any amount and it would be converted into debt. Okay, it would be converted into debt. Then the balance would be 1,000 minus 1,200. That would be minus 200. I should have taken a bigger number, but that's fine. Let's assume that it's converted into debt. So what's the expected outcome? What would you expect? If A checks balance, he should see 200 minus 200 is the balance. If B checks balance, minus 200 is the balance. But is that what both people see? No. A sees 1000 minus 700, 300 if he checks the balance now. If locking didn't exist, okay, so he sees 300 as the balance, which is wrong. And this guy sees 500 as the balance, which is also wrong. So if locking didn't exist, two parallel process would get conflicted. Like one process would see some other result, other process would see some other result. To avoid this, we take the outcome of both the results, we combine them and somehow log them. The process is quite complicated. All I can tell you is it's something that combines both the outcomes. And finally, instead of deducting 700 in one thread, 500 in one thread, you deduct the 12 minus 1200 at once. And now when these two users check the balance, after locking, it's minus 200 for both of them. So this is how locking works. Okay, this is a very high level overview on locking. Uh, we are done with sharding, locking, concurrency, and LRU cache. So that's most of it. How the database works. The retrieval, reading, creating, updating, etc. is very simple. You can understand them by reading the code base itself. So let's have a test of it. I've already tested it. The clear commands clears everything. So let's write the clear command to test it all the way from beginning. The web UI is not included in here. The web UI is not included. It's just to showcase the project. So I can just set user. Let's take D6 for one. Okay, the user is set. Next. This is like create command, and get is like the read command. Get user D6. So it should return the name, and it does, if you can see. Okay, so this returns the name. And what else could you do is you could uh, see the health. You could also see the stats, and you can also do something like set user. Okay, let me instead of typing some random thing and thinking so much, I'll say the syntax to some AI agent. It would give me some commands for it. Okay, also you can set a session. Let's name it session name ABC 123 and name it as active session. All right, let's name it as active session. It says okay, then it's fine. And then you can actually expire this session. Expire is same as deleting. You can expire uh, session ABC 123, and you should give a time here. Let's say I have given 10,000. Says okay. Then if I since I've deleted this session, if I do get session ABC 123. Okay, if I do this, it would show nil because it's deleted. All right. Now, what else could I do? That's it. We have all the CRUD operations we have seen. We can do clear. This would clear all the log entries. Yeah. Yeah, we can also do help to actually check all the commands. Otherwise, a new user won't know what are all the commands. Set, get, and expire, stats, health, etc. Yeah, these are all the commands. So I hope everyone contributes to this project and make sure you star it. That would really help so that it gets more exposure in the community. Thank you, everyone.